I'm going to record this as a whiteboard meeting. And I'm going to share the screen so we can all be looking at the same thing at the same time. So what we're going to go is we're going to go like group by group, right? And you're going to tell us a little bit about your problem. And then see if there are things like, you know, and this is the time where like I'm really hoping that the rest of you, as the group is explaining their problem, I'm really hoping that the rest of you are just going to jump in and just ask questions, right? Like, why did you choose this? Why did you record it that way? Like, why did you make those decisions? So we can just have like a organic conversation about how, you know, like, because again, there's so much of this is conventional, like it's about convention and personal choices that it's hard to pin down like a right answer. In fact, most of the time there is no like single right answer. So first one, Julia, Tate, and Dan. You want to talk to us about your problem? Like, give us.
Yeah, we were actually hoping to present the problem on the next slide.
You were what?
We were hoping to present the problem on the next slide. Question number 3. That one, yes.
Okay. I was gonna do number 3. I was gonna do number 3 like the second round. So.
Oh, okay.
That's why I said like specifically like I want you guys to work on number 2. But can you like, so without going into details, if you're not ready, could you tell us a little bit about your problem here?
All right. So our schema we apparently didn't include the bars as amounts of blocks, but we tried to make it to scale with these
no worries,
these highlighter marks, I think they are. Since our 2 moments that we're considering is just after the ball has left the person's hand and just before the ball is about to return to the person's hand, there's no potential gravitational force because there's no room for it to fall. All of its movement energy is in kinetic energy currently. And since there's no like air friction or friction with anything else, the thermal energy also stays the same at room temperature.
Okay. So those were your choices for that. Okay, let's look at another group. Let's see. Marin, Ramsey, and Ella R. Talk to us about your system shape. Talk to us about your system temperature and speed, and how you decided on energies and stuff.
Well, we decided that the system shape was unchanged, and at the end it was also unchanged, even though we didn't add like the specifics about how the ball's being unchanged, not just the shape. And there's no changes in property, and there's no changes in energy because they're all staying the same. And the system temperature stays the same because you can't really move. I mean, I guess you can move faster on the moon because I guess throwing the ball gives it potential energy, which makes it move a little bit faster, maybe. And then we also said that it stays the same for most of the rest too.
Okay. So one piece of advice that I want to give all of you is like really hark down back to your system properties. Like your system properties will determine whether or not if like, for example, if there is no change in property, there cannot be a change in energy, period, right? And that is like completely like waterproof solid, right? If there's no change in property, then there is no change in energy. If your property changes, then there might be a change. And then you can decide whether the changes, you know, things are going up or things are going down, right? So really, that's why it's important to really nail down the properties. It's because the properties will dictate what your LOL diagram is going to look like. So again, like I have no qualms with your solution. I just want to make sure that we're clear that really you need to go back to the system shape. So let's see, next group. Ella S, Hillary, Isabel, and Keen.
I can start. So for the process start, we said the system shape would be close to the moon. And at the process end, it would be closer to the moon. Or sorry, the same position as when it started.
Okay.
For the system temperature, we said a positive value T and a positive value or a positive value T because they're going to be the same. There isn't like any weather or air on the moon for like there to be friction force to like heat up or cool down the balls. So that's why we had that, and we thought the system speed would be the same, even though there's going to be, because if you look at like the question how it's worded, I don't think they want us to take into account like the ball going slightly faster a little after it's being thrown. So yeah.
Okay. The rest of the group, you want to add something?
For the change in property, the system shape did not change because it ended in the same position it started, and the system temperature stayed the same, and the system speed also stayed the same, and there's no change in energy. Yeah.
So can I push you guys just a little? I mean, again, like your solution is correct. Like, so there's like nobody, right? I just want to make sure, like there was something, right, in Kian's voice at the beginning, where he was just, he was very clear that the shape did not change, right? The ball was just above your hand, and at the end, it's just above your hand, so it's the same shape, right? He was also very clear that there was no atmosphere on the moon, therefore the temperature had to be the same because there was no friction. But there was some like hesitation about speed. And at the end, he made the argument that the speed was the same because he seemed like the text seemed to indicate that the speed should be the same. So my question is, right, Ella, based on your analysis right now of there is no change in system shape, there is no change in system temperature. Can you give me like a completely hard proof? Therefore, there must also be no change in system speed. Can we make that argument?
Yeah, if there's no like air force or drag on the moon, then the temperature stays the same. So the speed or the ball would not be affected by any of those. The speed would stay the same.
So from a purely like physics, understanding of physics and forces acting on objects, we can make that argument. Is there an argument we can make based on energy, since that's our topic? Anybody in that group? What do we know about the system?
We know the system's isolated.
Excellent. Okay, keep going.
Okay, so if the system is isolated, that means nothing else is interacting on it, right? And we can see that from our schema. So if there's nothing else interacting on it and it's only gravity, then the speed would be the same throughout the entirety. Well, not the entirety of the process, but from the start and the end.
Because if you had it change in just one and it's a isolated system, the energy wouldn't have anywhere to go, and if everything else is the same, there's nowhere else for it to go, meaning the speed cannot change.
That is a beautiful explanation, right? So you can use Ella's explanation about like, I understand the physics and forces and motion. If there's no forces acting on my object, nothing's going to change, and that's a beautiful explanation. And then there's Isabel's explanation, which is like the system's isolated. If none of the energies are changing, gravitational, EPGF, and E thermal, they're not changing because there's no property shape change and there's no property temperature change. Therefore, this kinetic energy has to be the same, right? And so it's not a question mark, like V is the same, question mark? Like it's V is the same, period. So that's great, that's a great, okay, so let's go to the other groups. Natalia, Hayden, Lowell, and Elliot. I love your diagrams.
For our schema, we just put the ball on the moon and we know it's isolated since there's no arrows going in or out.
Okay.
And for this table, we had pretty much what everyone else had, like system shape unchanged. So the potential energy never changed because the height was the same at the beginning and the end. Temperature, we wrote a positive value, then unchanged. So the thermal energy never changed because it's related to the temperature. System speed, we did positive value, then positive value unchanged. And we said the kinetic energy stayed the same because the motion stayed the same in the beginning and the end.
Yeah, and because everything stayed the same, that would mean like the beginning, like LOL diagram, and the end have to like be equal to each other. So they'd both stay the same, like same quantity.
Love it. That is a great sequence. Thank you. And then Chris, Ruby, and Lucian.
For our schema, we also put the ball on the moon, and we also know it's isolated because there's no arrows going out. And for our table, we had pretty much the same as everyone else's. System shape unchanged both at the start and the end. And the temperature the same and the speed the same. And we didn't put any potential gravity for our LL diagram because we thought it'd be all kinetic energy.
Okay. And based on the example we just did before, that's okay, right? If you know that your ball is not going to go any lower than where it's at, then you can call that 0 and be done with it, right? Or you could have given it at the beginning like 2 and just make sure that at the end you also have 2. I think we're done. Okay, I would like you to take a break, I think. Good work so far, right? Take a break. In fact, let's make that, see you guys back at 10.